Good afternoon, class. It's a very fine afternoon that we want to look at a very interesting topic here called index numbers. So, what are index numbers? Index numbers are just a series of numbers by which changes in the magnitude of a phenomenon are measured. When I talk of a phenomenon here, we are going to look at things like the price of commodities. We can look at the quantity of commodities. The quantities of commodities are measured from time to time. Maybe we can say, what was the price of petrol in 2010 as compared to 2021? That is from time to time. Or from place to place. When I talk of place to place, maybe you heard from the radios, TV, they are comparing the price of different commodities, maybe in Nairobi, as the price is in Eldoret, in Kisumu. So from place to place, we are comparing the prices or quantities of goods from time to time or from place to place. An index is constructed by selecting a base year as a starting point. So the prices at the base year, we will denote them by at 100. They will say they are at 100%. So the price and quantity of base year are represented by 100, and those of other years are measured against it. So we have different types of index numbers. Actually, we are going to look the two, the price index numbers and the quantity index numbers. When we talk of price index numbers, it just measures the changes in prices of commodities of the current year relative to the base year. So I have a small assignment for us. Let's just look at the factors. What are some of the factors you need to consider before you construct price index numbers? Factors like the price of commodities, the commodities themselves to select, the average will you use. So can you just look at those of the factors and try to outline them. Then we have simple index numbers. So when you are constructing index numbers based on only one single commodity, maybe it is the rice, you want to compare the price of rice in 2020 and 2025. So you are only talking of one commodity, which is rice, then that index number is called the simple index numbers. And the formula is the price index. This is price index is equal to P1 over P0 times 100, where P1 means what? The price at the current year. What is the price of the rice now at 2025? And P0 price at the base year. What is the price of that rice? Maybe you've taken 2020 to be as your base year. So for example, let's say P1, that is the 2025 price. Let's say the price 1 kg of rice, let's say it is 120 shillings. It depends which type of rice you are buying. P0, let me say I want to compare, I want to take my base year as 2020, and 2020, let's say the price of 1 kg of rice was at 90 shillings. So what is the price index? That is P1, or the price index will be P1, which is 120 over P0, which is 90, then I multiply this by 100. So what will this one give us? Let's use our calculator. So this one will give us, when I take 120, I divide by 90, then I multiply by 100, I'm having 133.33%. 133.33%. So what is the meaning of this? This simply means that the price has increased by 33.33% from 2020 to 2021. There is an increase in price of rice. So that is the simple index numbers. We are only considering only one commodity. Okay. There was a small blackout. Let's continue. Weighted index numbers. Weighted index numbers. So the weighting system is coming in because different people, they have preference to different commodities. Like when this index numbers is constructed in a coastal region, you know, the coastal people, they love pilau, rice, pilau, biryani, so they will prefer rice to ugali. So when the index number is constructed for different commodities, and you know different people, they have preference to different commodities, then weighting system is adopted. So we are saying this is adopted when the commodities selected do not have equal importance for the consumers. Then we develop what is called weighted index numbers. So we have different methods. These are the methods you can use to construct weighted index numbers. The first method is weighted aggregate method, and that is the method we are going to look at. And we also have weighted average of price relative method. But our topic will base our discussion mostly on weighted aggregate method. In weighted aggregate method, these formulas can be adopted. We can use the following formulas to calculate our index numbers. These are just the names of the economists maybe who are doing something on index numbers. So the Las Palles method, we have the Pasture method and the Fisher's ideal method. These are the methods we are going to discuss, or the formulas we are going to discuss when constructing our weighted index number. So let us start by the first method, which is the Las Palles method. Now this is the Las Palles method. So the Las Palles method, I want you maybe to write 1000 behind it. I'll tell you the importance of having that 1000 there. So the formula is price index due to Las Palles. Price due to Las Palles is summation PQ over summation PQ. So once you've written summation PQ over summation PQ, now bring your 1000. 1000. Just write it like that. So what does this mean? That means get the product of the price of the current year, that's the quantity of the base year, divide by price of the base year times quantity of the current year, then you multiply by 100. Always the index numbers are converted into percentage. So once you've written summation PQ over summation PQ, distribute 1000, and that is the formula. I'll be taking an example and you will see how that one is applied. Number 2, we have the purchase method, of which I've given it 1101. Now, price index due to purchase, summation PQ over summation PQ. Then I'm distributing my 1101. Then you multiply by 1000. Remember, P1 price at the current year, Q1 quantity at the current year, P0 price at the base year, and Q0 is the quantity at the base year. Now the Fisher's ideal is just trying to compare these two, the Las Palles and purchase. So to equalize these, the Fisher's ideal is just looking at the square root of the price index due to Las Palles times the price index due to purchase. So these ones I was dealing with the price indexes. Let's look at the quantity index, then we take an example. So the quantity index is just measuring the changes in quantities of the goods we produce, the goods distributed, or the goods we consume, the volume. Now the formula we can use to construct the quantity index numbers is the same as those formulas we used in the price index numbers, but look at where the difference is. For example, the last pairs, I've just given it 1,000, but instead of starting here with the P, since I'm doing quantity, then start with the Q. So QP, QP. Here it was PQ. Here it is QP. Just interchange. Then distribute your 1,000 times 100. Purchase start with QP, but then distribute your 1,101. And Fisher's ideal is now just trying to compare the two. So you just look at the square root of quantity due to purchase times quantity due to last price. Let's take an example. So I have an example here. I'm taking example about the price index, and I'll do another one about the quantity index. So I've started with the price index. This is the question. The following table shows the prices and quantities of 3 commodities: bread, sugar, and rice for the year 2012 and 2017. So by just looking at the 2 years, 2012 and 2017, which year is the most current year? The most current year is 2017, and now this will be your base year. So the price and quantities of the base year will be noted by P0 and Q0, where P0, price at the base, Q0, quantity at the base. The 2017 prices and quantities will be P1 and Q1 respectively. So that is the table given. We are being asked to calculate the last payer's price index, the purchase price index, and the Fisher's ideal price index. So I've started by calculating the last payer's price index. If you write the formula for last payers, then you need summation P1 Q1 divided by summation P0 Q0. So this is where I've worked my P1 Q0. P1 price at the current year, Q0 quantity at the base year. So when you multiply 20 times 180, 3,600. 80 times 1,200, 96,000. 50 times 640, 32,000. When you sum, you get this summation. And you also need summation P0 Q0. P0 Q0. Here now. The base year price and quantity. 100 times 20, 2,000. 640 times 80, 51,200, and 150 times 50. So that is, it sums to 60,700. So just substitute 131,600 divided by 60,700 times 100. So the price index due to last payers is 216.80. What does this mean? This means that the price of these commodities has increased by 116.80 according to last payers. The purchase price index is just looking at P1 Q1, P0 Q0. P1 Q1, now you will be out here. Price at the current year, quantity at the current year. 180 times 30, 5,400, 1,200, 12,000, 640 times 85, 1,200. Totaling to 176,600. And P0 Q1. P0 is here, Q1 is here. Multiply 100 times 30. So you multiply them, you get the summation here. You plug in the formula, you'll find it 223.54. So according to past years, the price has increased by 123.54%. Now Fisher's ideal is just the square root of the two price indexes. That's what I've done. 216.80 times 223.54 under the root, you get 220.15. So according to Fisher's ideal, the price has increased by 120.15%. So that is how we do an example of price index numbers. Let's look at the example when we are asked the quantity index numbers. Now I just want to use the same example, but now I just interchange the question, and now let's say we are being asked quantity. Remember here it was last year's price index, but now I've changed it to last year's quantity index, purchase quantity index, and Fisher's ideal quantity index. So when you look at the last year's quantity index, then the formula is summation QP, but I distributed the 1000. So Q1P0, the summation was 79,000. Q0P0, the summation was 60,700. So when you plug into your formula, you have the last year's quantity index to be 130.15. This means that the quantities has increased by 30.15%. The purchase quantity index, the summation QP. So Q1P1, the summation was 176,600. Q0P1, the summation was 131,600. When you plug it, you get 134.19. And Fisher's ideal is the square root of the product of the two. So when 130.15 times 134.19, you get 132.15. So this one, the quantities has increased by 32.15%. So that is how we do the price index and the quantity index for the weighted aggregate methods. Thank you, and I have a very small assignment for you. So let's do the assignment. So I have assignment here. Just try to work it out. It's about 3 commodities: maize, beans, potatoes. The prices are there. So I want you to do both quantity index and the price index. So this one is quantity. Please do also price index. And example number 2, try to explain some of the uses of these index numbers. You know the government need them. So just try to get the uses of index numbers and also try to explain some of the limitations of index numbers. And that is all about index numbers. I wish you well. See you next in the next topic. Thank you. It's done. So I'm